There are some constraints, which we call the inputs to the model, driving towards some goal, which is the objective function. And that can be either a minimization or maximization criteria of whatever you're trying to improve upon. And we will talk about how to create that objective function using weighting factors. Now, this is where we're heading. We're trying to find the optimal amount of stuff. So whatever stuff is, whatever your system is being modeled, to achieve the best that can be. And this is what it will look like when we get there. SimRunner produces a graph of the output of the value of the objective function for multiple runs that are being done. It also keeps track with the red line of what the best solution is so far, and hopefully at some point it will say, we're done, we've tried hard enough, we're going to show what the values are of the objective function, whatever that is. In this case, we're exemplifying profit, with whatever the parameters are that we're changing from one experiment to another. So that's where we're heading. In this case, we may have found that we have a profit of roughly 18,000, and that we know the number of operators, the batch size, and the whether we use a piece of equipment, or in this case a robot, or not. So here's what SimRunner looks like. It's a built-in tool within MedModel and ProModel. And what you do is you use it to either maximize or minimize certain key items, to provide what we call a pseudo optimization solution. I want to be careful calling it a pseudo optimization, because it is not pure optimization like linear programming, goal programming, integer programming, which are obviously very linear, deterministic applications we either use or have learned in school. But SimRunner is considered pseudo because it uses any simulation, which of course can include variation, randomness, and multiple replications. To do that, we must have a valid objective function. We need to have control parameters that we want to change, but we've got to be careful not to have too many control parameters, only because what SimRunner does is it designs experiments including multiple replications, and runs as many as are necessary to try to converge to an optimal solution. That can be very time consuming based on how long it takes to run each model. It's also very key to make sure that before you attack with SimRunner, that your model is verified and validated. In other words, is the model built correctly, and does the model meet the benchmark results correctly? SimRunner is one of the last things that you do in a model development. All right, one more example. This was done when the Army was vacating Iraq. So we had the drawdown from the stores and the forward sites in Iraq being pulled and delivered via truck down to the port at Kuwait. The purpose of this analysis was to try to determine the number of each of 3 different types of trucks that were available, and also to some degree try to figure out when those trucks are needed. The goal was to minimize the lateness of closing down the storage facilities, because there was a date. This was back in 2009, I believe it was. There was a date which they wanted to close each of the forward sites and bring all the material down to the port. What we can do is we can change the quantity of 3 different types of trucks. PLS means palletized load systems, and this is what they look like. They're very big, there are not very many of them, but they carry specific items. Standard intermodal to carry those boxes that you see on all the ships and trains and trucks around, so that's kind of standard. And then there was a certain variety of specialized trucks of different purposes called SP to handle like some of the some of the armament and ammo, for example. Now, the PLS trucks are very costly and scarce. The ISO trucks are more readily available, and the SP are moderately scarce. So there was a standard simulation aspect of scarcity of items. So we changeable parameters here with each of the 3 types of trucks within ranges. And the answer, excuse me, was that within an aggregate amount of lateness from the different types of storages out in the field, we yielded some range of I'm going to mute myself just briefly here. Sorry, I had to clear my throat. We look at a range of, 9 was the case with PLS, but there was a range of between 32 and 34 ISOs and between 60 and 70 SPs. That's what the SimRunner analysis yielded. But then we do further analysis. We say, well, what if we just did 9, 33, and 65? In other words, the mean number. And then go back and look at some further analysis on the result of that simulation. Standard simulation analysis yields that the trucks are very unutilized. But that's okay, because here's the key thing, when they're needed, they're needed. And further analysis of that shows that, for example, the PLS, see it says right there, PLS, are needed early in the, well, this is 2010, I'm sorry, not 9. Early in March of 2010, we needed a lot of PLS, and then that need diminished over time. So SimRunner helped us drive what we thought was a good range of best solution, and then we carried on with certain numbers after that to do further analysis, and we went beyond just this. So there was more analysis done after that.